And we're back. Sorry about that abrupt break. Okay, so we are building a schedule manager. Now, there are several ways that schedule managers can be implemented. It all depends on the amount of schedules that it needs to monitor. Um, For our purposes, we don't particularly need all that many schedules as such. We're not talking about thousands of scheduled entries. So the quick and easy way would just be looping through however many events are scheduled and then figure out whether we need to handle them or not. Um, an alternative way would be to, depending on precision and such, you could either split them out into um, uh, arrays containing subarrays for hours and minutes, and then again for seconds. And then from there add each individual event to each individual specific timestamp. That way you can um, uh, index reference the time of day within that structure, and then just do a check on how many entries are here, loop through those, so you don't have to loop through several thousands of events to check for a specific hour, minute, second combination. If it needs to be ultra high precision, then you would need to do something like calculate the millisecond for this particular event and then handle it from there. So it all kind of depends on what kind of precision is needed. For our setup, we're looking at the hour as well as the minute, and then we need to trigger something from there. But that also presents a different problem. Now, if this schedule manager loops through all of the scheduled events and finds one that matches the current hour and minute, then it should raise some kind of flag or action to have this particular thing actually occur. But we all know that within a minute there are 60 seconds, which means that this could potentially trigger a lot of times unless we do something to only have it trigger once. Um, so we definitely need to put in some kind of flag that determines whether this particular scheduled event has actually triggered or not, and then do things from there. We added in a, let's get rid of this quick. We added in a scheduled profile. The scheduled profile links to a specific host ID as well as the hour and the minute for the event and whether it's a backup or just a restart. This is highly specific to our purposes. Of course, if you need to build schedule managers for other things, then you need to kind of flesh it out with whatever features that particular schedule manager needs. For ours, we need to know whether it's just a restart or whether it's a backup. So we definitely need to put in some kind of events setup, events needed. Restart the server instance, do a shutdown, backup, and restart. Those are the two kinds of events we need. How we choose to handle those we'll figure out later. that's not something that the schedule manager itself should handle. It's something that we need to do somewhere else. Um, but for the time being, we definitely need to get something started here. So let's see about getting that up and running. We probably will want some kind of constructor for this. Whether we want to add in some specific things that we can pre-initialize it with, we'll figure out later. For now, we'll define it so we can put stuff in here if and when we need to. We definitely need to expose some kind of events. These will be the ones that trigger from the event manager when either this occurs or the other one occurs, depending on what kind of event is being scheduled. We also know that we need to be able to add them, and we may want to be able to look through the schedule manager to figure out exactly what's already in there. We also need to figure out whether we should remove a scheduled event after it has triggered in case we want to use the schedule manager to do delayed starts of each individual server instance. That might be something that we want to do. So at least internally, the schedule manager needs probably a few more configuration options than we have available at the moment. In any case, we do need some public methods, that's for sure, like so. And for one of them, we need to be able to add a schedule to the schedule manager. And the way to do that is that we can pass a schedule profile. We'll just call this schedule. We also may want to do it manually, so we'll add an overload for that, which would then be the server host ID, the hour, the minute, and whether it's a backup or not. We could also add in one that lets us do server host ID, date, time, I don't know, we'll call this schedule as well, and the backup flag. There we go. Now we've got different options for scheduling a specific event. We could also rename the add method to either be named something like add backup or add restart in case we want to make it that specific. I kind of like this approach a little better, so we'll stick with that. Right. Now to add these, we need to figure out a way to store this information so we can loop through it quickly and easily. And we also need to add in some kind of flag that determines whether this particular scheduled event has been triggered, and something that can reset that flag once the how should I put this, danger of reissuing the same scheduled event twice has passed, which would be 60 seconds later. On top of that, we kind of need something to monitor the current time of day so we can properly check the schedules and then raise the events as needed. Let's get these out of the way just to get rid of those comments. We need an event for a scheduled restart. So we'll just call it scheduled restart. Delegate void event handler, and it needs to pass the server host ID. Otherwise, we don't know which of the server instances this scheduled restart is for. Of course, we need the event itself for it. So we'll add that, and then we'll add in the restart method server host ID. There we go. And then we will go with this and pass the server host ID. There we go. That takes care of the restart event. The backup is a little different because it needs to be handled differently. So typically a shutdown, backup, and restart will take a lot longer than a regular restart will. So we will have to handle such scheduled backup. We'll have to handle those in a slightly different way than a regular restart should be handled. But like I said, these are things that we need to handle someplace else. The schedule manager should not be handling all this stuff simply because it's not its job to do the actual backup or do the actual restart. It's the job of a different piece of code. Let's get these declared. Backup event handler. Again, we need to know which server instance this is for. Event handler. There we go. And of course the method that raises the event. Invoke. And there we go. All right. So now we have the two major events that we at least know that we are going to need. So we'll pack these away and use them later. Next up, we need to figure out how to store this information within the schedule manager itself, and whether we need to be able to retrieve that information. That kind of depends on what kind of extra features we want to put into our project. For now, though, we will just stick with a kind of basic setup. So, scheduling structures, put those in here. We could just copy the schedule profile. However, we do know that we need some kind of extra information in terms of has this event been handled, and then some kind of reset for it as well. And for all of these different reset options for those flags, we kind of need to schedule those restarts 1 minute later, and then build in some code that specifically deals with resetting these particular flags. Those could easily be just another schedule, and then have it be a specific kind of schedule that strictly deals with resetting these event flags. And since that means a comparison, that easily takes care of the problem of these particular events repeating multiple times. for now, we will build in a internal handling of these. Schedule entry. We definitely need these public. We also need to figure out whether this has triggered or not. And we need to figure out what kind of event this is, because if this is a reset event that we do internally, then we basically don't need all this other stuff. We still need to find the correct time, as well as make sure that it's pointing at the right one. Though one of the things that we can do is we can do these by indexes instead. So one of the things that we could do is just, no, actually, we'll see how this turns out. Yes, we definitely need this one. Determines whether the scheduled event has triggered. Is this a backup event? There we go. Okay. Next up, we need to figure out whether a specific next up we need to store these in some way. So we'll just throw these into a schedule entry. Welcome back. There probably is. And we'll grab this one and set it to 0. All right. So in terms of handling these, we could return a boolean that determines whether this particular schedule was added or not, and return that whenever we attempt to add a new schedule. Whether that's useful or not kind of depends, but we definitely need to add in some kind of we need some kind of way to determine whether this is just a reset event or whether it let's see. How are we going to do this? We could cross-reference these so we don't have to loop through them. Let's see, yeah, we'll do reset index. We'll hold the index of the schedule entry to reset. Okay. That should suffice. Then we need to figure out a way to add all this stuff. I'll do that down here. But before we add it, we should probably loop through the list to see if that schedule already exists. If it does, then we'll simply ignore adding it because it's already there. The way to check that is, of course, to verify the server host ID, the event hour, the event minute, whether it's a backup or restart event. So we'll start by looping through here and see if that particular event already exists. Now these two, we can simply just call the other one, which means it needs the host ID which is this one. It needs the hour, it needs the minute, and it also needs the backup flag. There we go. And this one is pretty much the same. So server host ID for this, it would then be the hour and the minute and backup. There we go. And then here we'll figure out whether this particular entry exists already. And if it doesn't exist, then we will add it. And on top of that, we will add an extra scheduled event which contains the reset. So let's start by looping through this and seeing if we can actually find a matching schedule index. All right, which would be the schedules, and there we go. All right, so the derpiness is real. All right, we know that we need to look for the server host ID, the hour, the minute, and the backup flag, and we also need to ensure that reset index is set to some value that is outside the size of the array. So for that purpose, we are simply going to set the reset index to -1. That indicates it's not a reset event, so we definitely need to check on that. So if this reset index is -1 and the server host ID equals the past server host ID as well as the event hour and the minute, whoops, there, minute, as well as the backup. There we go. Hey there, James. Welcome to the stream. And I'll just do this quick so we can see what's actually going on here. So if all of these conditions are true, then we actually ended up finding an identical event. So for that purpose, we will set the index and then break out of the loop. Now, the only instance where we really want to add a schedule to the schedule list is if index ends up being -1 after looping through the existing entries in the schedule list. So if this one is -1, that means we didn't find this particular schedule profile, so we need to add it. All right. For that purpose, we need to resize this one. Yes, absolutely, and that's actually what I'm doing at the moment. However, the batch file is not able to instruct the server to shut down and do a restart. It's not able to do a shutdown, backup, and then restart, and it's not particularly easy in batch to set up specific restart and backup times. Well, let me put it this way. Let's see. That would be the wrong one. This would be the right one. This is the batch file that I've got running right now. The problem with this is I can't exactly set this one up to restart at specific times, which is something that the server actually does need, especially when running modded. I can't exactly instruct this batch file to say shut down the file at 4 in the shut down the server at 4 in the morning, do a daily backup, and then start up the server again. Um, Simply can't be done in a batch setup because there are no features for scheduling a specific thing to be done within that batch process. The alternative way would be to mess around with the task management system that comes with Windows and then do some schedules in there. But again, those particular tasks are not all that well suited for, say, a backup process. Plus, they can't always correctly monitor whether a specific instance of Java has been shut down or not. That's kind of the reason why I'm building this particular server launcher. And if you give me just a minute, I will do a quick showcase of it again. This one we need to add another entry to. Um, the reason for adding this is so that we can store the actual restart profile. So we shall do that. Now at the moment we don't exactly have any kind of initializer for this, so we'll do that quick. Actually, while it is here, we can do a quick startup. There we go. This is what it looks like at the moment. Through this, we have options to pre-configure memory sizes, where the server resides. We added in a nice UI for manipulating the server properties file, so we can more easily and quickly set up a server or change some kind of setting so we don't have to mess with the text file. Quick and easy stuff. That's basically it. And this one, at the moment, I have a vanilla profile set up. I also have one for a older version of Minecraft with Forge mod loader, where I've added in Railcraft. So I have done some game development in C#, yes. The project that I have planned to be the next one on stream is going to be about a kind of game development, one that is sadly walking the way of the dinosaurs, the really old school multi-user dungeons based on text games, which were accessible through the use of a standard telnet client. That's something I'm kind of keen on doing as the next stream project, because it involves a lot of different aspects of programming. There's networking in there, there's scheduling stuff in there, there's session handling for individual players, there's data synchronization between locations, specific player event handling, items going in and out of inventories, and all sorts of cool stuff in there. And I plan to do that in C# as well. For the moment, though, it's on the Minecraft server launcher. One other thing that we're currently building a restart/backup scheduling manager, which will allow us to specify, say, at 4 in the morning, I need you to shut down, say, this Railcraft-based server, do a full backup of the game world, and then restart the server. And then again at say 5 in the afternoon do a regular restart, just to keep it running smoothly. One of the downsides of running Minecraft in Java is that it tends to kind of drown in on itself when it's been running for a long time. So these restarts are kind of mandatory. For huge vanilla communities, some of them restart every 8 hours. And for the smaller ones, they might just have a single scheduled restart once a day where they do a daily backup just in case. It all depends, but especially when running modded servers, you definitely need to restart at least once a day. Some, depending on the mod pack, of course, you kind of need to do at least two restarts a day. And if you really want to make sure that you at least have some amount of backup on your stuff, you also should do a daily backup. And this particular Minecraft server launcher will be able to do that when running it from a Windows system. And yes, I am fully aware that hosting and running Minecraft servers on a Windows environment is about the worst setup that you can do. But if I really wanted to run this on a Linux box like I should do, then that would mean a third computer running at my house, which, well, let's just put it this way, adds quite a bit more to the electricity bill. So at the moment, it'll just run off a Windows box that runs 24/7 anyway. So um, that aside, back to the schedule manager. All right, so we need to add in some kind of setup here. Um, well, it definitely sounds like an interesting project. Can I ask what genre of game you've got planned? Event minutes, and whether this is a backup. This would be for a regular scheduled event. So server host ID equals this one. The event hour, not handler, hour, equals this one. The event minute equals this one. And of course the backup equals this one. Now, since we're scheduling a new event here, we definitely need to force this one false because we don't want to have it fire right away. We also need to set this one to -1 because this is not a reset event that we're setting up. For the other instance, we kind of need to do the same, except we need to add in the reset index. There we go, and then configure this. There. That takes care of that problem. And just to get rid of those warnings, we'll do a build. There we go. All right, so we've added one to the list, and then we need to store the information. So there we go. And that would be a new schedule entry, grabbing the server host ID, the event hour, the event minute, as well as the backup flag. And here, oh, that's because it's just hour and minute. There we go. All done. All right. Coming to an agreement is not always easy. Um, the reset index that we need for the next one is a little trickier. And the reason for that is that, or rather, the next event that we need to schedule would be the one that resets whenever one of them has triggered. So we don't have to loop through them every single time and figure out, do we have to reset this now? We can simply just schedule another one. So we need to store the position of this entry that we just added, and then we need to do a little bit of trickery because we need to schedule this one interesting. Um, just to put it out there, does any one of you know anything about networking? If the answer to that question around the board is no, then A, you either need to go find a network specialist, or B, you need to look into some kind of MMO library that can handle it for you. And I can tell you right off the bat, finding a network library that's capable of handling MMO networking sessions for games is going to be about as easy as taking a walk to Mars. I'm not trying to kill your idea for a project or anything, but it's something that you definitely need to be very aware of. Networking for MMO games is not an easy thing to accomplish. It is rather complex and rather difficult to do. Fair enough. All right. So, how do we go about handling a reset 1 minute later? Um, oh yeah, ask Blizzard. They know. They know from hard and bitter experience how difficult it is to, how should I put this, build MMO code that can actually handle the pressure. Um, Skyrider and I, we were originally part of both the closed betas and the open betas, and both of us went on the live servers on launch day during the first hour. And I kid you not when I tell you that Blizzard Entertainment's entire World of Warcraft networking setup crashed about 1 hour after launch, simply because it wasn't up to snuff in terms of handling the sheer pressure that players put on their game servers. And the entire world login was down and completely unresponsive for, I believe it was something like 6 or 8 hours before they got it fixed and finally got it working again. They know by bitter experience how difficult it is to build it. Okay, so we need to add the entry that will force the triggered flag back to false when a specific schedule has been actually triggered. One thing that we definitely need to do here is figure out how we can schedule this next entry 1 minute later than the actual event itself. And the reason we need that is because we are only looking at hours and minutes. Of course, we could do this a little more expanded by adding in seconds and then just have it trigger 10 seconds later, then that might be a little easier for us. Actually, why don't we just do that? So we'll add in another one here for event seconds, like so. And then for this one, we will simply set it to always be 0. There we go. And if this is a reset for this particular one, then we can simply just schedule the second 10 seconds later. That should be enough. There we go. Then we actually don't have to do any kind of calculation. The only thing we need to do is add the same schedule entry, but append the index position of the previous event. And since that then sets the reset index within the schedule entry itself, that then becomes our custom internal schedule entry that will take care of resetting the triggered flag for the previous one. Nice. All right, so let's get this on the road here. Since we're effectively adding the same schedule once more, we're doing that so we can ensure that we have the correct reference to it. That's definitely something that we need to keep an eye on. So by adding the same schedule entry, but also adding the reset index, then we can make absolutely sure that this particular event hasn't been tampered with. Yeah, a lot of people want that, definitely. All right, so we can now add to our schedule manager. We have the ability to schedule a specific event to happen, and we have the ability to configure a reset of the flag that handles whether this particular event has been triggered or not. What we still don't have is something that actually does the time monitoring. So true. Yeah, I know that one way too well. All right. So how do we want to go about this? And how precise do we need this to be? As such, we don't need this to be particularly precise, but we might as well do a thread like we've done before. Oh yes, absolutely. And while you're at it, you might want to grab your current network code building skills and experience, and go investigate how to how should I put this, protect your data. There are a lot of malicious people out there that either want to disrupt your service or want to try to somehow inject changes to the data packets going back and forth. Say, for example, a perfect example would be an aimbot for Counter-Strike. The way it works is by tapping into the network connection and modifying the network packets. So that's definitely something you need to keep in mind, and you also need to keep in mind that you should never have your server trust your own game client. That's part of how you accomplish, how should I put this, better detection at how somebody at the other end might be manipulating data. Encryption is not enough. Any kind of encryption, and I really mean any kind of encryption, can be decrypted. Yep, exactly. All right, so let's see. We should probably add in a disposable support. There we go. And just for the sake of it, boom, then I don't have to write it. Yep, fun times. We'll move this stuff down here. There we go. And clean it up a little bit. Oops. Da, 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 da. Da, 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 da. All this stuff we don't need. Whoops. However, we do need to put in here there we go. And here we need to thread starter call like so. So we can start up the schedule handler whenever we instantiate this. And then we should probably put in some code here to see if we can get this running. So schedule monitoring thread. Talking for so long really upsets the voice a bit. Anyway, okay, so we definitely want to monitor current time of day. And we probably also need to be able to break out of this at some point. We need a startup and we need a shutdown. So let's put all those different things in here. We need a thread for this. So let's add that in. Let's just call it monitor thread. We need a flag that determines whether we are still running. Yeah, we'll just call that running. Put that false. And then we need a couple of methods. We need one to fire up the thread. We need one to stop the thread, or rather, we don't exactly need a stop as such because we can just set the flag and then wait for it to shut down. Yeah, we'll just do that. So we'll just add in a method here, start monitor. There we go. This is just so we can handle starting up the thread, and then we'll monitor schedules like so, and this one will be the main loop. There we go. Right. While running, do this. There we go. We actually need to add in volatile. There we go. So we can mess with it without interfering with the threads. Yeah, there we go. We did do the events, didn't we? Yes, we did. All right, cool. Right. Okay, so to check this, we kind of need to figure out what the current time of day is. So we'll grab current hour just because we can do it this way. There are several different ways these things can be done. Some are more efficient than others. I'm not particularly building this for the sake of efficiency or less coding or less typing. I'm doing this in this way for greater understanding of what's actually going on in the code. So absolutely. There are way more efficient ways of doing this, a lot of this stuff, but like I said, it's for the purpose of showing a greater understanding of what's going on in the code. Doing things in highly compressed methods and lambda calls and whatnot. I find that a lot of people have trouble figuring out exactly what the code does, and the primary reason why I'm doing these streams is to try and grant a greater understanding of what the code actually does and how you can force the code to do something that you want it to do. In any case, we kind of need the current time, so let's grab the hour, and we need the minute. So we'll grab that, and we also need the seconds because we're also checking on the seconds. So let's grab the seconds. There we go. Now we've got these. All right. So next up, we need to loop through all the schedule entries to see if one matches. So let's do that. As less than, nope, not mbox schedules. There we go. All right. Oh yeah, that's very nice progress. So are the planets, how should I put this, generated as well, or is it just sort of a star system generator? All right. No developer can ever get by without a good cup of coffee. And saying that, cheers. Ah, coffee. Greatest invention ever. All right, so we kind of need to see if this particular schedule matches the current hour. If it does, then we can check further in. Some would say, why not just match all of them? Well, it's a question of oh yeah, it's definitely the first thing when you buy when you start programming. Actually, I think I went about 2 years of programming before I tasted coffee the very first time. And I was 10 at the time and didn't like the taste much. Anyway, well, we could easily just do all three of them, whether it's needed or not. Debatable. I guess we can put them in there. Um, oh, okay, so the actual planet environment is generated, or the surface as well. Nice. Very nice, James. Okay, so um, if the hour and minute match, then let's see if we've got one that matches on the seconds. Um, if we find one that matches on the seconds, then we probably need to do something about this one. From there, we need to check if the reset index is a positive value or a negative value to figure out whether it's a reset event or if it's one that should be triggered and whether it has been triggered. Um, so first we do a check here. Um, this is some kind of event we have to handle. All right. So is this a backup restart event or a um, reset thingy? Okay, then yeah, biomes don't really matter all that much. Unless you have some kind of resource gathering in there, then biomes might have an impact. Um, okay, so the thingamajig that we need to check first here is we need to figure out whether this is something that might be an event that should be raised or if this is just a flag reset. So the way to figure that out is to check whether the reset index is -1. If it is, then we need to figure out whether we have to actually reset it. If it isn't, then it might be an event we have to raise. There we go. Nah, biomes are not all that difficult. All right. So this appears to be a reset thing, or sorry, the -1 is the one that is an event we might have to raise. So to figure out whether we have to raise this event or not, we need to check the triggered flag. The reason for doing that is because we could end up going through these checks multiple times during the time span of a second. Um, so if the triggered flag has been set, then we need to ignore it. So check whether the um, triggered flag has been set, and that would be a not. So if it hasn't been set, then we need to figure out which kind of event we need to raise and then pass server host ID. So quick and easy. Let's see if this one is a backup. Now, if this is a backup, then we need to raise the schedule backup right there and pass the server host ID. There we go. And in all other cases, we'll assume that it's just a standard restart. So we'll do a restart and pass the server host ID for it. There we go. And once one of these two has triggered, then we definitely need to set this flag to prevent it from triggering again. So since we already have a pre-declared way of handling these two kinds of events, we'll set it right away. This then prevents these particular events from triggering multiple times within the time span of a single second. So that takes care of this. Now, if the reset index is a positive value, then it should be pointing to a previous profile, schedule entry profile. So to make sure that we have the right one, we'll do a quick check and make sure that they are identical. So let's grab the reset index quick, just to make it a little more readable. There we go. And then if the reset index is greater than or equal to 0 and less than the length of the schedules array, then we should be good. There we go. Right? Now that's for the client. All right, so let's see. S is the current profile, and reset index will then contain the entry that we actually need to reset. But before we do that, let's verify that they are actually identical. So if this one, reset index server host ID equals current one, and I'll do this quick so we can better keep track of what's going on. The reset index, the event hour equals the current event hour, and the same for the minutes. There we go. Event minutes, and sorry. Finally, no, you're right about that. But in terms of that, you really should take a look at how other games handle that. One of the major things about doing any kind of multiplayer game setup is that you kind of need to cheat your way through things, otherwise you're going to end up having extremely large amounts of data that has to be transferred back and forth. So in terms of one player looking in one direction and the other player looking at that player looking in the other direction, the way to cheat your way through this is by simply synchronizing the direction they're looking at and then letting the client figure out what part of the player avatar needs to be animated for showing, say, body movement or whatever. That's not data that you really should synchronize between game clients, because you would have to synchronize that entire blob of data up to your server and then out to all the other clients that are in that area to correctly synchronize those. And before you know it, if you have 1,000 players looking at each other, then you have like 10 million copies of the same piece of data that goes back and forth. And they are very quickly becoming very big. So in such a case, you definitely need to not do that and cheat your way through synchronizing only what's absolutely needed. If you take a look at a simple game like Minecraft, the primary way that Minecraft handles synchronizing the direction you're looking at is by only sending the actual position of the avatar, what direction the avatar is pointing in, and what direction the head is pointing in. Those are the only pieces of data that are ever synchronized. But since the avatars in Minecraft kind of have body movements, that is something each individual client handles internally. And that data is never synchronized over the network. Only the movement and position. That's it. By doing it that way, you can easily have thousands of Minecraft players, though the server won't be able to handle it, but in essence have thousands of Minecraft players standing at the same location, and all of them would look like they move around and they jump up and turn their heads and turn in different directions and whatnot, and they're all animated. But that's something the client handles primarily. That's not something you should transmit over the network because your data blobs will simply just become astronomical in size. So in a lot of game development, cheat tricks like these are implemented strictly to reduce the sheer amount of data that is being transferred between all the clients and the server itself. It's all about cheating, but achieving the illusion of, say, um, synchronized animation across clients. So cheat whenever you can get away with it, especially when you're doing game development. You seriously have to cheat as much as you can get away with without breaking the illusion. That's the most important part. Yes, exactly. Um, when an avatar starts moving, whether it be an NPC or a player or an animal or a monster or whatever it is, if the server instructs the client, this particular entity is now moving in this direction at this velocity, then the client should pick up that change and switch to an animation that matches whatever the server tells the client to do. Um, but if you look at the actual data that goes from the server to the client, the only piece of data that goes there is effectively here's the start point, here's the end point, that's the velocity. So you're only um, instructing the client to go to a new location in a specific direction at a specific velocity. That's basically three tiny pieces of data, and then the client handles um, all of the animation that matches this particular change. That's how you should properly synchronize entities within your game, because you're then reducing the amount of data that has to be transferred back and forth. Exactly. You always have to reduce the amount of bandwidth that you're spending, not for the sake of your clients, but for the sake of your server. The reason being, if you're building, say, an MMO with, say, 50,000 players connecting to your game, then every time you have to update a single avatar's position, direction, velocity, whatever. Let's say you instruct this particular avatar to go from point A to point B at this velocity. Then you effectively have to copy that change 50,000 times, one for each player that's connected to your game server. And if you include things like animation synchronization and such, you could easily end up with having data packets that are, say, 10 kilobytes in size, just to synchronize the animation information. And if you calculate that up quickly, that's 10 kilobytes times 50,000. That's a lot of bandwidth that you have to spend just to synchronize the animation. However, if you reduce it down to, say, 12 bytes of information being sent to each client, then it's 12 bytes times 50,000, which is way less bandwidth than having to send those huge blobs of data back and forth. So it's all about reducing the bandwidth for your sake, because when your game at some point goes live on a box somewhere where you're renting a server in a hosting environment somewhere, then you will be accountable for every byte of data being transmitted in and out of the server that you're renting, and you will be paying for that bandwidth. So as much as you can reduce the bandwidth spendage for your server, that means higher profits for you and less expenses. And if you're running, say, a gaming environment where um, it's somewhat expensive paying for the bandwidth, then the less data you can transmit back and forth, the cheaper it will be renting that particular server. Um, um, you mean what the game server handles? Well, for the most part, if you're building a multiplayer environment, and it doesn't really matter what kind of game you're building, whether it's an RTS or an RPG or first-person shooter, whatever, as the instance that you're uh, upping the stakes to some kind of multiplayer environment, the primary task of the game server itself is always to maintain the data structures that make up the world and the contents within the world, and nothing else. So if you're doing, say, a space shooter MMO, then the primary job of the game server itself would be to handle positioning of, say, spacecrafts, players within space stations, the space stations themselves, where stellar objects are, like planets and comets and whatnot. Um, it maintains strictly positional data for those, some kind of health bar if you can attack space stations, for example, some kind of destruction information, and that's it. Um, and the major job of the server itself is to keep that data synchronized to every connected game client, and that is basically it. However, on top of that, you should always make sure that the information that the server retains has priority over what the client says. The biggest mistake made in Minecraft is that the client is the one that dictates to the server what's going on. The reason that's a mistake is because it's very easy to manipulate the server into believing that this particular client did this particular action and that this particular action is legal. So the server should always have priority. The server dictates to the client what's accurate and what is in effect an illegal move. Um, that's what you need to keep in mind when you design the game server itself. But it runs the major part of the simulation that handles all the content. So if you're, for example, let's say you grab a space shooter of some kind, something like Freelancer, for example. If you have scripted events where, say, you have a convoy that travels from New Berlin to some other system, then part of the server's job would be to execute the simulation of these ships moving from system A to system B along these prescripted paths. Or if it's something that is done by means of, say, pathfinding, then the server would first of all figure out the path, then execute having the convoy follow that particular found path and do that positional simulation. And the game client itself would then take those instructions, positional instructions from the server, and render the graphics accordingly. So most of it is a matter of figuring out exactly what makes out the core of the game, and then effectively transferring that to a dumb box that does all this. And if no player is connected to that dumb box that does the core mechanics of the game, then uh, either pause the simulation, or if it's a persistent universe, you need to continue the simulation, regardless whether players are connected or not. It kind of depends on what kind of game mechanics and what kind of game world you're building. And you're very welcome. And with that, I think I will take another couple of minutes break and take care of my upset tummy quick. So I will be right back.